Hello, welcome back. I'm Andreas Chatt, your tech-curious web designer. First, a shout out to my new supporters on Patreon. A fist bump to Yamusa and a high five to Cars and EV20 Questions podcast. Thank you so much for your support. I really appreciate it. Okay, and now let's get started. In this video, I will show you how to set up a S3 packet to store our media files on AWS. This is Amazon's web services. So S3 stands for Simple Storage Service. And it's pretty much an industry standard for storing files in the cloud because it's highly scalable, reliable, and very customizable. This service is not free, however, and you need to provide credit card details to create an account. But it offers a free tier for a whole year. Additionally, I will show you how we can transfer our image files from Cloudinary over to AWS. Okay, that said, let's have a look now at the steps required to connect our Django application with a S3 packet. So first we create the S3 packet where we will store our images. Second, we add an access policy to this packet which defines who has permission to access it. As the third step, we will create an admin user to whom we will grant access to the packet using the IAM service, which stands for Identity and Access Management. Fourth, we attach a permission policy to this user and give him full access. Fifth, we create a public and a secret access key, which we need to authenticate our Django app to AWS. Sixth, we install the package Django Storages to connect to our S3 packet. Seventh, we install the package Poto3, which lets Python communicate with AWS. And as last step, we set up all the AWS configurations in our Django application. Okay, let's get started now by creating an account on AWS. So this is AWS website offering this free tier, which we will be using. And this will include a free storage for 12 months with 5 GB storage space. Okay, let's create a free account. Add your email, create an account name, and fill out all the required information. You will also be required to add a credit card, but it will not be charged in the first year. We're choosing here the basic support plan. And then finally, we are signed up. Let's go now to our console. We sign in here with the root user we just created. Later, we will also create an IAM user, which has access to the packet itself. Okay, and this is my AWS console. So first let's create a S3 packet. So in the search bar here, we search for S3. This is the service we need. We can also highlight this, so we have a shortcut to it. And then I click S3. Then here I click Create Packet. Here I select the region which is closest to me to have faster loading times. Then we create here packet name. So this is a globally unique name. So I call my packet awesome-aws-packet. Then here under object ownership, we leave it at the default ACLS disabled. So ACLS stands for access control lists. And we use them to give ownership to this packet also to other AWS accounts. Then here we have a section to block or allow public access to our files. We want to uncheck this option to allow public access to our packets because we want our files to be visible on the internet. This is a high-level setting. We will see a more granular configuration by creating a packet policy in a second. Then we also click this checkbox here to acknowledge that the files will be public. Okay, and then we click Create Packet. And our packet is successfully created. Now, as mentioned before, we need to create a packet policy to make it truly accessible to the public. So let's click on the packet. Then under Permissions. And here we find the Packet Policy section. We click here Edit. Then we click Policy Generator. This opens a new page to generate this policy. So here we select S3 Packet Policy. Here the effect is Allow. Principal, this describes who we give access to our files, and we give access to everyone, so we use the asterisk here. Under Action we define what operations users are allowed to perform, and we want to select here the getObject operation, which allows users to retrieve an object. Okay, there it is, getObject, we click this one here. And here under Amazon resource name, we get the name from the previous page. So let's go back. So here we see the bucket ARN. Let's copy the name and paste it in here. And at the end, we add a slash and an asterisk. That means the policy applies to all the content in this bucket. Okay, and then we click Add Statement. It created this statement here. And then we click Generate Policy. And there we have our packet policy now, written in JSON format. Let's copy those lines and go back to the previous page and paste it in here. All right. And then save changes. Then let's go back to the buckets list. Let's refresh here. And as we can see here, this bucket has now public access. Great, this was the first part. So as next step, we create the IAM user, who has the permission to write to this bucket and represents our Django application. So let's search for the service, IAM. Here it is. I also highlight this service and click on it. Then let's go here to users. So far we have 0. Let's click here, create user. Then we give it a username. So I call it andyjudd-admin. Then here I click provide users access to the AWS Management Console. Here I'm selecting I want to create an IAM user. Then we create here a password. I choose custom password. And here I'm unchecking user needs to create a new password on the next sign in. This is recommended for security reasons, especially when dealing with sensitive data. But in my case, not necessary. Okay, and then I click next. Here you have the option to apply the permission to a whole group or just to one individual user. So in that case, we just attach policy directly to the user. So I select this option here. Then we search for the permission policy we want to add. And I want to give this user full access to the S3 bucket. So I'm searching here for S3 full, and there we have the Amazon S3 full access policy. So I select this policy here, and then click next, and then create user. All right, our user is created. Let's return to the users list. And the next step is to create access keys, which we need for our Django application. I'm clicking on the user here. And in this section here, we can create access keys now. So I click here, create access key. This is a list of use cases. As we want to add the keys directly in our application, we select local code here. AWS recommends to use an IDE instead for security reasons. However, I will be using environment variables to store the keys. So I click here that I understand and want to proceed. And then next. We can add some description tags to the keys, but this is optional. And then we create the access key. Alright, the key is created. It is actually a key pair with a public and a secret access key. So let's copy first the access key and add it to the env file in our Django application. Here I'm going to my core folder, to .env, and here I create a new variable. So this is the AWS underscore access key underscore ID, and paste it in here. Now the next variable we have to add is the AWS secret underscore access underscore key. So let's grab this value as well. Is this one here, and paste it in here. And the third one is the packet name. So AWS underscore storage underscore packet underscore name. Let's go back and grab the packet name. We retrieved our keys, so I click done and continue. I navigate back to my S3 packet. And this is our packet name. So I copy the name and add the name in here. Okay, save this file. And our environment variables are set. Obviously, on a live site, we would need to add them to our web service as well. Okay, so we can close this file. Let's go now to our settings file. And here, before we add the AWS configurations, I will install two packages we need. And the first one is Django Storages to establish the connection to the S3 packet on AWS. So I shut down the server here and say pip install Django-storages. And the second package we need is Poto3. So this is the AWS SDK for Python, so the software development kit that provides an API to interact with AWS. So let's install it with pip install Poto3. Okay, that's now installed. I will just quickly upgrade pip as well. So pip install --upgrade pip. And I also add them straight to our requirements.txt file. So we say pip freeze, then the greater than symbol, and requirements.txt. Alright, and now let's add the AWS configurations. So first let's find the documentation online. So I'm searching here for Django-storages. Then here to the documentation. And as we can see here, with this package we can connect to many file storage backends, such as Amazon S3, Microsoft's Azure Storage, DigitalOcean, Dropbox or Google Cloud Storage. Let's check out Amazon S3. So we pip installed the package already. To configure it now, we need to add a dictionary. This is a new change since Django version 4.2. We can see here the old version was just to add this line. Now Django requires a dictionary. We can also check out the official Django documentation on this. So I'm going to Django docs. And here I'm looking for storages. Then I click here on File Storage API. And we can see storages is new for Django 4.2. I click here the storages link. And we can see here the default declaration for storages, including the default storage for our media files, as well as a static file storage. Okay, let's go back to the package and grab the code. Then in settings, I go to my media file configurations. There it is. At the moment, I'm using Cloudinary, so I comment this code out and paste the new AWS configuration in here. I will get rid of the options because we don't use them for now. But what I need to add here is also the static files configuration. So let's go back to the Django documentation. And I'm grabbing those lines here and paste them in here. There we go. So the default storage for user uploaded files will be the S3 bucket now. We could also store the static files on AWS, but for now I keep them stored within our Django application, which is the static file storage. Okay, the storages are set up. Now let's add the access keys. So first we have the AWS access key ID, which takes the value from our environment variable. Then we have the secret access key. And finally, we have the storage bucket name. Alright, so with this information now we can connect to our S3 bucket. Let's save this file and test to upload an image. So for this I switch to my remote database. So I change Postgres locally to true. And then start up the server. Python manage to py run server. Then I open up my website at localhost :8000. I refresh the page. So loading the page will take now much longer as we are connecting to the remote database from our local environment. Alright, there we go. We are connected now to our remote database. And as expected, we lost all the links to our media files, which are still stored on Cloudinary. So these are our category icons and the user avatars. But before we transfer them over to AWS, let's test to upload a new profile image for our admin user. So I'm logging into my admin interface. Here to profiles, then to admin, then choose an image, then save. And let's see if that worked. I go back to the home page. And great, as we can see, the avatar image was uploaded. Let's inspect this image. And as we can see here, the URL is built up by the bucket name .s3.theregion.amazonaws.com/the avatar folder path. Then we have the file name, and then we have a couple of attached parameters for authentication. However, we actually don't need those parameters because our files are public. So let's get rid of them now and make the URL much shorter and simpler. For this we add an additional configuration to our code. So this is the AWS _S3 custom domain. So here we construct our domain now with just the essential components we need using an f-string. And that would be the bucket name. I copied the variable from here. .s3.amazonaws.com. Alright, let's save this file and let's check it out. I refresh the page, then inspect the image. And as we can see, the URL is now much shorter and cleaner.
Nice.
So next I will also add a configuration to prevent a file with the same name to overwrite an existing one. So here we can add AWS _S3 file overwrite. And we set this variable to false. By default, this is set to true. So AWS will create a unique name now in case a file with the same name already exists. Alright, save this file. And let's quickly inspect our S3 packet. I click on the bucket name. And as we can see here, we have our avatars folder created. However, to keep files more organized, I want to store all user uploaded files in a dedicated media folder, in case I want to store also the static files in this bucket in the future. So let's create a new folder here. I call this folder Media and create folder. Alright, now to save all our media files to this folder, we need to add a configuration. So let's get back to our code. And here I'm adding AWS location and set it to media, which is the name of the folder. Alright, let's save this file. Now let's upload a new profile image. I go to my application. Let's go to the admin interface, the boss. Then I go to profiles again. Then to admin. Then I choose a new image and save. Back to the profile. We got a new image here. Let's check the URL. And as we can see, it uses the media folder here. And if we check the bucket, we have here this new image, stored now in the media folder. Awesome. Okay, we are done now with the configurations. Now let's fix all the missing images on our website. Those are still stored on Cloudinary, so let's go there now and download them. To download images, we go to the media library. This opens a new window. Then here we go to folders, then to our media folder. And we can see we have an avatars and an icons folder. So we want to download those two folders. But if you're working here with a live site, we have to make sure the users are not uploading new files while we're doing this transfer. So we need to temporarily block the access to our website. And we can do that with a maintenance landing page. If you're interested in learning how to create one with Django, check out my deployment tutorial video part 10. Alright, when we are ready, let's download the media folder. I click here on media and download. Okay, the folder is downloaded. Then I unzip the folder. I rename the folder to Cloudinary and move it temporarily into my project folder. Alright, we have the folder now in our project. This is handy later on when we will need the path to this folder. Okay, next I upload these two folders to my media folder in the S3 bucket. First I get rid of the avatars folder here, we don't need this folder. We move this one already into the media folder. So I need to put here permanently delete in the input field. Then delete objects. Alright, then I click the media folder and upload my folders in here. You can click add files or simply drag and drop them. Then click upload. Alright, all our files are in the bucket now. Let's check out the website. I refresh the page, but as we can see, the images are still not linked up properly. Let's inspect the link. I right-click to inspect an image. And when we look closer at the URL here, we see that we have 2 times the media folder, as well as the file extension is missing. Let's check it out also how the image is stored in the database. Here I have an avatar image and we can see the media path is already stored in the database. And again we have no file extension, and this is because Cloudinary stores just a unique identifier for each image in the database and dynamically generates the URL of the image on the fly to deliver the image with the most efficient extension and optimization. Let's compare this with how we are storing the file now with AWS. I go to the avatar image we just uploaded before, and we can see how we need to change the path now for the images to show up, getting rid of the media path and also add the correct extension. Okay, let's do this now, and for this I'm writing a script which compares the files in the folder with the objects we have in the database. So back to the code. I'm going to my scripts folder here and create a new script, and I call it Cloudinary to AWS.py. And this script now will need to have access to the database and the models in our project. But this will not work without actually initializing the Django application itself. However, to make it work just inside the script and without actually running the local run server command, we need to set up first an instance of the Django application. Let's see how this is done. So first we need to import the system module to set the path to our application. And this is my path to the application on a Mac. You need to set yours accordingly. Next, we need to tell Django where the settings file is in our application. For this, I am importing the OS module. So my settings file is in the a_core folder, like this. And as last step, we have to initialize Django. So let's import the Django module. And with the setup function, we initialize Django. Alright, now we can write a script to interact with the Django components that runs independently from the main application. So the first script will update all the avatar image links in the database. I create here a for loop which iterates over all the files in my avatars folder, which is located in the Cloudinary folder within this project. If you have a different path to the folder, you need to change this accordingly. And then I add here a print statement to see the progress of the looping in my terminal, and I just display the file names. And then I'm using here the method splitText to split the file name into two parts, the name part and the extension part, which includes also the dot. And to capture those two values from this method, we define two variables in front, like this. So we have here the file name without extension and the file extension. Alright, so far so good. Now as next, we search our database if there is an object with this file name without extension. I wrap it in a try except block. Then I'm defining here a variable, image in the database, which is made up by the media and avatars path, and then the file name without extension. Then I'm grabbing this object with obj equals, then I'm accessing the profile table, .objects.get, and I'm looking up the image property, which is equal to the variable we just created. Alright, let's import profile now. So from a_users.models import profile. So if this object exists, we update the image property with a new path. So obj.image equals the avatar's path plus the file name, which includes the extension. And then we save this object, obj.save. And then I just add a print statement that this object was indeed updated. I say updated, and then the value of the image property. Okay, like that. And then I also add the except block with pass. Meaning we ignore files which don't correspond to any object in the database. Alright, let's call this function now and run the script. Save this file. and click the play button on top. And as we can see, it is looping through the files now. And it successfully updated some avatar images. Awesome! Let's check them out on the website. And there we go, our avatar images are showing up now. Great! Let's repeat the same now with our category icons. I duplicate the code block from here. Then I change the name of this function to update icons. Then we access the icons folder. Then in the database it is saved with the icons path. Then we change this to icons here as well. And we want to fetch the objects from the tag table now. Alright, let's import the tag class. From a_posts.models import tag. Okay, and as last we update the function call. Alrighty, this should be all now. I just comment out quickly the avatars function, we don't have to run this again. Save this file and run the script. It is looping through the files and updates the path. Nice! This is done, let's check it out on the website. I refresh the page. And voila! Also the category icons are here now. Awesome! So we transferred now successfully our images from Cloudinary over to AWS. Now we don't need the Cloudinary folder with the images anymore, so I can delete it. Delete this folder. And mission complete. Alright, this was the last video in this deployment tutorial series. Thank you so much for watching and following along, and I hope you learned also something new. Now for the next videos I will focus again more on the fun part of introducing new technologies into a Django project with some magic sprinkles of HTMX. If you like this content, please subscribe to this channel, add a comment below that you subscribed, that would help a lot with the YouTube algorithm, and if you want to support me also financially, I have a Patreon page set up at patreon.com/AndreasChat. Thank you so much. Alright, I hope to see you in the next one. Stay curious my friends, and bye bye for now.